Hi again, everyone. Welcome, or hopefully welcome back to another episode of Reliability Matters, the podcast where we talk about all things reliability, how to achieve it, maintain it, and push the boundaries of what's possible in electronic assembly. Today, we're continuing our deep dive into the world of soldering materials, from advanced alloys and flux chemistries to global manufacturing strategies and materials innovation, with one of the industry's most respected leaders. Joining me is Ross Berntson, President and CEO of Indium Corporation. Ross has been with Indium Corporation for nearly 30 years, starting as a product specialist and rising through the ranks with leadership roles in product management, technical support, and international operations. He even spent time leading Indium Corporation's Asia holdings while based in Singapore, strengthening the company's presence across Southeast Asia. In his current role as CEO, Ross sets the strategic direction for a global materials powerhouse, one that's known not only for its high-performance soldering products, but for its commitment to innovation, collaboration, and engineering support through the company's one engineer to another philosophy. Ross holds degrees in chemistry, teaching, and an MBA from Cornell University, where he earned several prestigious academic awards. He's also deeply engaged in both the electronics industry and his community, serving on multiple boards and leading with a strong emphasis on culture, opportunity, and respect, the core of what Indium Corporation calls the Indium Way. In this episode, we'll discuss how soldering materials are evolving to meet the demands of modern electronics, from miniaturization and harsh environments to UHDI and advanced packaging. We'll also talk about Indium's unique positioning in the industry, the challenges of global supply chains, and what the future of soldering looks like from the vantage point of a company that's helped shape it. And it all starts right now. Stick around.
Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Konrad.
Hi, Ross. Thanks for joining me today. It's great to have you.
Great to be here, Mike. Thanks for having me.
It's my pleasure. I have rubbed shoulders with many of the people that are team members at Indium, and over the 40 years I've been in this industry, it's always been impressive. There's definitely, in the intro, I talked about the Indium Way, but that's clearly from a bystander standpoint, that seems to be a little bit more than a tagline. It definitely, there is a uniqueness about the company and the way it puts itself forward. And I'll tell you where
it's a really special place.
Yeah,
It
it's
really
definitely that definitely is a curated culture, to get that many people all connected in the same way. Where I first really discovered Indium was many years ago. I mean, I always knew about them, but where it really called my attention was, back in the Rick Short days, your old, VP of marketing or whatever position, title he held. And he ran this video campaign about, obsessed about solder paste. And it was slightly irreverent, funny, very funny, in a very dry world. The engineering world is not known, to do stand-up mic nights at comedy clubs, right? So it really stood out, and it was effective. It didn't take itself too seriously. It was funny. It left an impression. It got people talking. And this was in an era before it was common for corporations to produce video content. It was all print ads and email campaigns and boring stuff. And this was totally out of left field, particularly for this industry. And I just loved seeing the progression of those types of ads.
And they're still available online, and him running through, taking his clipboard and then going through a wave solder machine and coming out with, solder stuck to his beard.
Yeah, molten solder icicles. Yeah. And then I think the one that kind of capped it off, and this may have been kind of the last of his career there, was one of the early videos was him giving his daughter, wasn't really his daughter, but a young girl, 5 or 6 or 7, 8 years old, a Christmas present, and she unwraps it. It's a tube of solder paste, and she looks at him like, "What the heck is this?" Right? And And then the last ad I saw, I think that he was involved in, was her as a young adult opening a tube of solder paste as a Christmas present and appreciating it. You know, she drank the Kool-Aid, but that was like
this is
a generation.
Just to interrupt for a second. So that young lady, Annabella, is now working at Indium. So all these years later, she's now joined the team and joined the family. And she's not a family member. She's just now part of the Indium family, though. She started off all those years ago. So she's probably in some ways the longest running employee of Indium.
Right. and speaking of long-running employees, you've been with Indium about 30 years. So clearly you started when you were 7. Child labor was a big thing back then. Before we get into the weeds on soldering materials and all of that, and the materials industry, tell me about your journey at Indium, where you started within Indium and how you kind of worked yourself up through the ranks. And I assume at some point the board of directors went, "You're next. You're the next CEO." So tell me how that progressed for you.
Yeah, I mean, I'm really fortunate. I'm one of the few people probably in the world today that got to start off at a company and then just grow through the ranks up to CEO. It just doesn't happen that often. And I'm so blessed to have been at this great company. You talked about our culture earlier. The Indium way is absolutely part of how we work here, and I've gotten to experience it. So here I was a chemistry teacher back all those days ago in the early 90s, and I got my chemistry degree and was teaching down in Maryland. Fell in love, was going to marry my wife, who's a veterinary student down in Ithaca, New York. And so I needed a job. And she clipped this ad out of the newspaper in Syracuse, New York, out of the Syracuse newspaper, mailed it to me. I mailed my resume to Indium, and they contacted me, and I got an interview opportunity and really started off as a tech service. And I can't imagine the combination of my teaching and my kind of science background entering into this company with a tech service mindset, this idea that we're going to go to our customers, spend time on their factory floors, and really get to know how they're using our products. And then that enabled me then to learn and then become a teacher myself. And the key moment probably was, we Motorola back in those days was one of the big dogs on the planet, right, for electronics. I think one of the sales guys who brought me to my first floor visit said, "You can ask as many questions as you want. And this is a friend of ours. It's okay." And I think I spent 2 hours on the factory floor asking questions.
Took advantage of that offer, right?
Yeah, and that culture of spending time on the factory floors and learning and then disseminating that information and then learning and disseminating that information to help us create more value for our customers has really been the core to how I've grown up at the company and the core to how we still create value. You mentioned in your intro from one engineer to another. I really lived that early on in my career, spending time with the design teams, the engineering teams, the process engineering teams at our customers, figuring out what do they need, and then bringing a product to market that delivers on that need. You might remember back in the 90s, we had a product called the 92 series product, the 92J. It was a tin lead product all those years ago. That was one of my babies that I really got to work with. And it was so fun to bring this material across the globe and really help companies improve their printing, improve their reflow, improve their probe testing, improve their reliability through the application of that product.
Yeah, well, we don't live in those days anymore. That product probably wouldn't work for half the stuff. Well, first of all, it's got lead in it, so
right.
Your market is limited. But so much has changed, and we're going to get into that. The new challenges. You certainly picked an interesting industry because I think the electronics industry in general, and of course materials specifically, it's like a video game. Once we complete one level, the next level is almost exponentially more difficult and more challenging, and there's more things that can metaphorically kill us, and there's more trapdoors, and we have fewer lives left, and we have to learn the new rules. The rules change on us, and Moore's law is challenging, right?
Yeah, and you talked about we have a saying here that we believe material science changes the world, and every great advance in human history has been accompanied by a major advance in material science. So, and I've got to do that at Indium. Our culture, I talked again, melds directly with how we do innovation here. We when over the years, I've had the privilege to work on so many new products where we engage with a customer on asking them, what are your challenges? What do you need? And then we come back and we work hard on bringing a product to market. And then I've gotten to see that product meet that customer need. That need almost always becomes an industry need and then keeps growing from there. And it's just been so fun to see that business cycle happen over and over again at Indium. And that builds out new product lines. A big part of our growth has been we're committed to all of our customers, large and small, specialty, niche applications and mega huge high volume applications. And because we treat all those customers with a lot of care, a lot of personal touch, we're able to be the partner of choice. I think when someone has a new idea or something they want to experiment with, we have enough creativity and flexibility in our culture to allow us to try something, get a product in their hands that they can test, and then bring it to market. And so, like one example of this might be, we have a lot of thermal interface materials. Indium is this really, it's our namesake element, but it's also a really special element. It's a great ingredient in so many solders for improving reliability, but it also is a phenomenal thermal interface material. And so when you start looking at these most advanced processors today, the use of indium as a thermal interface in CPUs and in thermal management of, let's say, these especially ASICs for AI processing, that all started back in the early 2000s with indium preforms used to create better thermal interfaces to the backsides of die. And I got to be a part of those early days of bringing that technology to market and expanding it. And now today, it's one of our largest markets.
Yeah, thank goodness that the founders of the company that came up with the name chose an element that wasn't like, your company could have been named lead, for all that, right? And talk about, running the company into the world of obsolescence, right?
Right.
And tin's just not sexy. And I guess gold would be there, but yeah, indium certainly works. Before we kind of get even deeper into the weeds on why you're here, one other comment. You mentioned the word value a few times. I speak on entrepreneurship and marketing at universities mostly. And one of the things I discovered is this concept, which I coined, which it turned out I never coined. I coined it, but it was already out there. So I can't take credit for it. Is this conscious marketing idea, which is, basically if you want to sell your product, stop talking about your product, connect with the customer, provide value, and identify what the issues the customer is facing, present best practice solutions, and then the customer is smart enough to draw the line and connect your products with their need for a solution. If you just start talking about XYZ product without the context, without making an emotional connection, it's just noise, right, at that point. And I think in the From One Engineer to Another video series, the blogs, the webinars that I've seen, particularly from your company and a few others, but particularly from Indium Corporation, it definitely follows that philosophy of value first, product later, because product doesn't make sense before there's a value-based connection, an authority-based connection. And I think what Indium's done well, and a few other companies and within our industry in general have done well, is to become an influencer within their space. And I'm not talking about Kim Kardashian, TikTok type influencer, but an authority-based influencer. And I think your company has done a really good job at navigating that. And I believe you were fairly early pioneers of that philosophy, because when you guys were starting to do that, everyone else was still, making noise. And it really stood out. And now, probably thanks a little bit to Indium and other companies that have, picked up on that, other companies are starting to recognize that too. And which is good, because obviously the tide raises all ships, right? So what's good for the industry is good for everyone in it. Indium Corporation has a long history in the materials space, nearly 100 years. It's funny to think that you started there 30 years ago, and the company was almost 70 years old when you started, right? So it was an old company when you got there. From your perspective as CEO, how do materials innovation and reliability work together, especially as devices become more compact, that's an understatement, and operate in increasingly harsh environments?
Yeah, so the mission profile of these new systems are changing all the time. We're seeing it in terms of how, let's say, electric vehicles need a different type of solder solution, or maybe in the thermal space, or an AI company might need a different type of solution for how they're going to manufacture or process their device. And so, as we've looked at the mission profiles change, that requires material innovation, and often the initial solution doesn't end up playing out, or might actually sit on the bench for a long time. We've had technologies, and I think this is really, again, fits with our ability to work on small projects and let them mature over time. To your point, when you focus on value for the customer, we're not in a position where we are just saying, "Hey, we have this product. Will you buy it?" We are in a position of saying, "What do you need?" And then sometimes we have to invent something new. But because it's a dynamic industry, there's almost always 3 or 4 ways to solve any problem. So our solution might not win in that moment because the technology and the value profile isn't there. But because we don't abandon the technology, we allow it to germinate over time. Sometimes it can be maybe 30 years or 15 years later that a technology all of a sudden emerges and goes, "Oh my gosh, this is that technology's moment." And so as we look at, so going back to what your question about how do we deal with things getting more compact or more demanding, the mission profile is getting more demanding. Well, so it starts with what do they need in the final assembly? But that's not the end story. Then we have to back up to how do we manufacture? How do we make it a manufacturable product? And then we got to back it up. How do we make an economic and manufacturable product? And then how do we scale the production on our end to be able to bring that and package it in a way that allows the customer to use it? So just it's sometimes fun to think of an example of this. So we had customers that had a mission profile where they needed higher reliability than our traditional tin, silver, copper alloy, but they needed a lower processing temperature. Well, that's really hard to do, right? So you got to get to a lower processing temperature. And by the way, you couldn't incorporate any new defects, no new voids, no new solderability challenge or anything like that. And what that ended up leading to is us tapping into a technology we had for about 13 years, which is a mixed powder technology. We brought that concept into a new alloy system, and we're able to bring to the customer a more reliable ultimate solder joint that met their mission profile, but could be processed at their temperatures that they needed, which was much lower, almost 40 degrees lower in peak temperature. So those two things combined, but it all was possible because of an innovative approach that we took to a completely different problem, 13 years earlier. And that product is our Durafuse LT, and it's really an exciting product, but it's the idea of how do you create that in the first place? It needs a lot of patience, needs the willingness to allow people to try and experiment and try new things, and then also patience with a technology so it can have it stay when it comes to the right time.
Yeah, and I've had my company for 30 years now. As long as you must have started around 1992 at Indium?
96, about 96 is when I started.
96, okay, 96. So coming up on 30 years. I started my company in the cleaning world within our space in 1992. And over the 3 decades, we've been presented with challenges and we've created a concept of a product that we thought it was a great concept, but it couldn't find the right market for it, whatever. And I learned a long time ago, rather than, burying it and, having a memorial service, just stick it on a shelf. And inevitably, almost without exception, these old ideas come back. Or
Absolutely.
Another idea that was, to your point, for challenge A became at least the foundation for a challenge B solution. Mm-hmm. And we basically MacGyver old ideas, parts of old product, technologies, software, whatever the case may be, and use it as a parts or toolbox. And all of a sudden, these tools work on this application. So it never say never, right? It's ever evolving. Sometimes it's revolutionary, and sometimes it's evolutionary, and both work.
Right. Well, and sometimes there's this other thing that needs to happen, which is a new processing technique needs to become available that allows the technology to flourish. And so another story I love is the story of our informs. which is actually a product developed by a guy named Paul Soka back in the 80s. I mean, this is really throwback, way back there. And all of a sudden, it had a little bit of a life. It had its day in the sun in the 90s, and then it kind of settled down and was quiet for quite a while. And then one of our really innovative engineers said, "Hey, I think this product could work in this application." I literally said to him, I said, "I don't think it's ever going to work, but go ahead and try it. Let's see if it goes." So I had to eat a little crow later on, because guess what? He brought it to the customer, and it worked great for creating a more reliable interconnect for a large area attach. And this technology what made it possible to work now, when through most of my career it didn't work, was the advent of formic acid and vacuum soldering, which was not really readily available all those years ago, and certainly not readily adopted.
Yeah.
And now that technology is pretty the mainstream technology for assembling power modules. And now it's getting even more interest in other applications. But that inform technology that's so important for EVs today started off with a completely different application space. And the key enabler was that vacuum solder and reflow capability.
Yeah. I talked earlier about our industry being like a video game, where every level is, much more difficult than before, and with new challenges. And within that context, given the current geopolitical uncertainty, volatility in raw material availabilities and supply chain challenges and things like that, how do you ensure that reliability remains a top priority while scaling production, while growing a company, while fighting geopolitical stuff, tariffs, supply chain, material availability, all the stuff that would keep a CEO up at night in any company within our space?
Yeah, well, I mean, just the geopolitical piece is a big part of it. Having a robust supply chain, both on incoming materials as well as a robust supply chain to our customers, is so important. So we've been taking on a mindset of make it where we sell it, and to a large extent. So we have factories around the world that assure the supply chain. And then in terms of reliability, one of the most important aspects of that is, especially for our global multinational companies, is that no matter which factory you get your material from, it has similar characteristics, can perform day in, day out. Every single jar of solder paste or every single preform that comes off our lines, no matter what factory, will perform in a predictable fashion. And so we spend an enormous amount of time in our quality systems, in our internal reviews, in our internal audits, in our way we engage with scale up and APQP processes for bringing on a new product for the automotive industry, for example. That discipline we bring across the platform. So by the time we get to scale, we've ironed out the issues. We've demonstrated our ability to produce the product inside of our core capability set. And then we've also distributed that across the globe, that know-how. Now, that's just within our factories. Then there's how do we make sure we assure the reliability to the customers that they need? And this comes back to maybe designing, the way we think about our products is designing a robust, wide process window product so it can work in multiple factories, multiple setups. That's always important. But probably to the customer specifically, the most important is that it meets their mission profile at the end of the day. Their final product coming off the line is going to deliver what they need. And different areas have different concentrations of know-how. Like in Korea and Taiwan, they do a lot of packaging and system and package, where it's really critical, the tight spacings. And for example, in Germany and Central Europe, you have a lot of automotive customers, so they care about the automotive mission profile. And what that means for those different companies are not necessarily the same. There's themes that align, but the specific needs are what matters. And that's where our specific engagement with our engineers, our R&D people, with those user sites, with those development labs, with those R&D teams, it is impossible for us to create the value we want to, as we talked about earlier, without making sure we fully understand their mission profile and what they're trying to achieve. And that's what our global team is it's just in our DNA to do that. We engage with these companies on a regular basis with technology roadmaps, where they share their roadmap, we talk about ours, and we make sure we're targeting the right destination for both them and for us. And then that allows, once we get that product, it allows us to activate our entire quality system to make sure we deliver it to them every single day.
What role do you see AI, artificial intelligence, and machine learning playing in the future of product development? And how might these technologies help your customers build more reliable assemblies? Are we seeing a line between AI capabilities and ultimately reliability?
Yeah, so AI right now is obviously just in terms of it's the most advanced technology that's out there right now in terms of packaging, in terms of system demands. And so we are spending a lot of time thinking about how do we make sure we meet that specific market demand, which is drawing the entire, I guess, the entire R&D kind of ecosystem at Indium forward into bringing new materials to market. So that's not really, I don't think, the core of your question, though, but it is a really exciting space just in its own right. But how do we use AI to actually bring a new product to market or innovate with a product? And right now, a lot of it is being used in the rest of the business. So maybe it's more of the business process optimization, the creating more efficiency in the way we run our day in, day out, the way we do our sales processes. So that's not directly on product development. But when we are more efficient in those areas, we both have more resources and more time to do development. So now if we go directly into, okay, how do we actually use AI for a new product design or a new product idea? And I think that's the core right now, because we don't have the database necessarily to train the AI in specific materials for us. It's really using AI to come up with those creative solutions. There's a great book a while back by a guy named Epstein who wrote Range. And he talked about the fact that one of the ways to get new ideas is to take ideas from disparate areas and bring them together into a new domain. And then that can create new ideas for you. And in many ways, AI allows us to do that. We can ask creative questions, ask it to help us come up with a new way to approach a problem. And there has been some work from some universities and other areas where there's been some new ideas of materials that can be brought to bear, some new ideas of how to maybe manufacture something or how to assemble a material to help it meet that mission profile in a brand new and novel way that we would have never thought of. We're starting to see some of this in alloys and alloy development. But right now, I think where I'm most excited, and it's not directly AI, but it is going to be the fuel for AI, is digital twinning. Is the ability to create a digital twin to a circuit board or to a semiconductor device or to a whole assembly that creates a set of stress conditions, response variables that allows us to feed into a digital twin, then to do modeling. And then that modeling can help us understand the material properties that are driving different failure modes or different, to your point, the reliability becomes paramount. How can we reduce the cost of assembly and increase the reliability and do that iteration quickly and therefore drive the material science properties? Now we might have to go chase the materials that we will fulfill those property needs. But that is where I think we're going to see the first advent of real AI impact. And I'm very excited about that.
Yeah, as am I. I think that the rate AI is expanding and quantum computers are growing. I think that by the time this episode, we complete recording this episode, it'll be twice as more capable as it is before we started this conversation. It just grows so fast. Flux formulations, the chemistry side of solder paste, often receives less attention than the alloy side. Flux is kind of the poor stepchild, right? It's a typical Brady Bunch where where flux is the Marcia, because Marcia's getting all the attention, and alloys are Marcia in this case. What are some of the most important trends or challenges that you're seeing in flux chemistry, particularly with finer pitch applications and low standoff components, UHDI, things like that?
Mm-hmm. Yeah, well, with obviously forming the solder joint is one of the easiest tasks of the flux these days. It's the ability to remove the oxides, transport them to the perimeter, and create a nice bare metal surface for us to create a good intermetallic. That's kind of table stakes these days. What we need to do is figure out what are all the other challenges, and processing becomes one of the biggest drivers for the flux chemistry itself. Is how do we get the printing performance? Very often the stencil design rules are being violated with some of these new devices. We're doing for the system and package tools. The spacing and the pitches are very tight. So the flux has a huge demand on it to be able to perform with very fine powders where now you think about the surface area goes up with the square of the diameter of the powder going smaller, right? Just surface area just keeps expanding and expanding and expanding. And so that surface area has more oxides. So now we have this flux chemistry that needs to be able to handle the printing and the stability at the printer. But then we have this other challenge, which is with the finer powders, we have more oxide. And then you add all that together is very often these devices need to be underfilled or there's some post-assembly process that needs to occur that requires interaction with that flux chemistry. So you just imagine all the dynamics here. You got a great rheology, fine powder, so great reflow characteristics, but then you have to have very low residue and or very soluble with residue to be able to transport, clean it off so we can have that high performance. And we're trying to balance all those, and everything has a little bit of a trade-off right now. Some of the more interesting aspects of what's happening in the industry. Remember earlier I talked about the fact that there's new reflow technologies out there. There's new ways of thinking about how to process things. Those same new reflow techniques are creating new opportunities even in these fine feature devices. Is there a way we can have almost a zero activator flux or a low activity flux or a low solids flux that can still deliver that performance that we need? And that's an area of investigation right now at Indium in collaboration with a lot of companies to see, can we deliver that? So these residues after the reflow become really important. And how do we minimize them? How do we clean them? How do we make sure they don't create a secondary issue while delivering all the performance we need for the main chemistry in the assembly process?
I spoke to an engineer, not an indium engineer. So no, after you hear what they said, no witch hunt, Ross, no witch hunt.
Okay, gotcha.
It wasn't one of yours. And it was at a conference. They were speaking on low temp alloys and the advantages of low temp solder. And I have no argument with all the advantages of low temp solder. But I did ask a question. I said, well, with you make a no clean low temp solder. Yes. Okay. I said, how does that work from a chemistry standpoint? Because the idea of no clean is that once a certain temperature is reached, the bad actors volatilize, and then you get this encapsulation of some of the activators. So it renders, at the best case, it renders the assembly and the residues inert or encapsulated. So cleaning may or may not have to be performed. I said, when you don't hit the traditional reflow temperatures, we've done studies that show that if your peak reflow temperature is as much as 5 degrees lower than the minimum recommended, we see that in an SIR result, right? Because the activators are still doing their job. They're still activating, right? They're still failing an SIR test. So I said, have you come up with new chemistry that activates at lower temperatures, in terms of removing the activators and performing encapsulation? And he said, no, it just, you probably need to clean it. And I'm like, wait a minute, 2 words on the label, no clean. And I'm like, what about activation and all that? And he goes, yeah, we concentrated on the alloy, being able to reflow properly and bond and, do all the intermetallics and all that stuff. The flux is the flux. Like, okay, yeah, I guess we're going to be selling cleaners to those customers, which is a good thing, right? Right. Go forth and multiply, right? Make it so. But that's an interesting dilemma there.
Absolutely. Yeah. Well, no clean is really all throughout history. No clean has always been a process, not a material. You can take the best in class no clean solder paste, let's say, and if you process it wrong, it's no longer reliable because the process wasn't a no clean reliable process. And I think that speaks to what you're talking about here, that if you're going to have a low temp system, the entire system has to be designed for low temperature, and subsequent processing still needs to be within the right parameters to deliver it.
Yes.
It's not, you can process it however you want and still get a reliable outcome.
Right. They got the alloy down. They just didn't get the chemistry part down. And they probably do now. But that was almost like, well, we don't really care about the chemistry. Again, to the poor stepchild, analogy there. You mentioned the word earlier, trade-off. Let's talk about trade-offs. Many manufacturers struggle to balance production efficiencies, optimization, and all that with long-term reliability. Sometimes there could be a trade-off. What best practices would you recommend to help engineers make better decisions when selecting soldering materials that are efficient, that are sustainable, that check a bunch of ESG kind of boxes, yet they don't negatively impact reliability?
Yeah. Right now, I would say the number one thing right now in the industry is keep an open mind. There's so many new ideas. I mean, we have all of our new ideas and new ways of thinking about things, but keep an open mind. Go into the world and talk to your suppliers, talk to the equipment vendors. Very often the printer companies and the reflow companies have new ideas that they can bring. We're very thankful that we have an incredible network of companies around the world that we work with. And the collaboration in the industry right now amongst companies is really exciting. It allows us to bring new ideas and advance those ideas faster. And so number one thing is we're trying to figure out how do we balance all these trade-offs is stay curious, stay creative, allow yourself to go into a direction that might not make perfect sense right away. And then let's try some things together. I think getting to some minimally viable products, trying to create a test vehicle that simulates the biggest risk profile that we're going to have in that final assembly, and then doing iterative testing is one of the most important things we can do right now, especially if someone wants to be at the cutting edge of cost, productivity, reliability. It's going to require some work. It's not just going to happen with hey, I got the solution, here you go run with it. It's going to require some real work, but that work doesn't have to be super costly in time or materials. But a well-designed test vehicle with a little bit of testing, a little bit of clarity on experiments and what we're trying to find in our response variables can deliver a great outcome. And that's what our engineers here, I mean, that's one of the biggest things that I encourage our engineers to do as they're working with a customer. Get to a minimally viable product. Get to a gross reality check test. Find your test vehicle. Find your response variable. And let's get busy with the customer and help them see with us, shoulder to shoulder, how this could possibly create value. And once you get that vision for what's possible, then we're on our way to getting a full system.
When supporting customers in industries like automotive and aerospace, defense, medical, high-rel customers, what are some of the most common reliability concerns they encounter, and how does your team and your products address those concerns?
Yeah, well, we talked earlier about the alloy being the dominant force, and I think in this case, especially. Yeah, and especially in this case, and the applications that we're talking about here, I really do think the alloy becomes critical to many of these challenges. So, probably the two big areas that we see customers struggling with, one is a crack joint where they said this joint, this capacitor or this CSP is giving me a failure under the mission profile, the rigorous thermal cycling or the vibration testing I'm doing. We got to get these cracks solved. And often a way to do that is create a stronger alloy or a softer alloy, one of the two. It depends on the scenario. Mm-hmm. Okay, so now we get this alloy, which can deliver that mission profile, which is great. But now we go back and we say, now how do we actually process it? And then the other thing that creates a big challenge in many of these applications, whether it's automotive or space, is very often these devices we're trying to assemble have high thermal demands, right? They're generating a lot of excess heat. We got to get that out of the components to, again, achieve the reliability. But many of the high reliability alloys can have wetting challenges, voiding challenges. So they create this secondary defect mode. And so what we've been doing at Indium is trying to balance those two always. How do we create that ultimate joint that delivers the performance the customer really wants, but make sure that we're getting the end of line performance for the voiding and is still processable under reasonable conditions. And this is where I mentioned earlier this mixed powder technology that we invented all those years ago, but we were able to bring that together here where we're able to combine a really the best of both worlds. Add something into the system that allows us to process efficiently in the line, but create the other ingredients that are necessary to create a reliable, more ruggedized solder joint, and do that without creating any extra voids or secondary defects. And ultimately, that's led to our Durafuse series, whether it's a high reliability or a low temperature system, or now our high temperature system. But it's all based on this creative notion of how do we mix powders together? How do we create this best of both worlds kind of approach? It's a journey, and all of those developments have surprises. You get into that. I talked earlier about creating the right test vehicle. You get into that mode of, okay, we got the idea, we've proven the concept, now we start to ramp. That's when you really need a company that's going to stand shoulder to shoulder with you, and help you solve all those millions of little problems and little challenges that come along the way. And fortunately, we've been successful at bringing these products to market. But I can't wait to see what's happening next, because there's new mission profiles coming out. There's more rigorous thermal cycling requirements coming. There's a desire to process at even lower temperatures for sustainability, but even have higher reliability because of the demands. Just one example would be some of these companies, they used to have a situation where you would say, we turn on the system and it just runs. Therefore, we need just elevated temperature, long life at operating temperature. And so it doesn't thermal cycle as much because you're operating within maybe a more narrow range. But now, because of maybe battery life, or because of energy consumption and making it have a smaller green footprint or a better green footprint, now we have it either on peak and high power or off. Now we're going for on being instant demand to instant off to instant demand to instant off. That stress on the solder joints is enormous.
Yeah.
And we're still uncovering those challenges now and working on solutions. It's like I said, you talked earlier, there's more and more constraints, but that just creates more and more opportunities for material science.
Sure. Yeah, absolutely. Sometimes the best intentions produce complications, and you talk about the solder joint stress when you're on an on-off state, regularly. I compare that to modern cars have the feature that turns off the engine once the car comes to a stop, say at a traffic light, and then the engine will instantly start back up so you could go, or near instantly, not instant enough for my liking, but you feel a little surge, and I have to think that was well intended, because the entire time one is stopped at a traffic signal, we're not putting greenhouse gases in the air. We're conserving a little bit of fuel, and two check marks for the environment. On the other hand, now there's a starter motor that's turning. That's stress on the engine. When things start up, they're going from a zero state to a certain RPM and fraction of a second. That's got to be hard from a reliability standpoint, from a functionality standpoint. And overall, how much are we spending to have that, whatever measurable impact that is on the environment? What's the flip side of that? That's the trade-off, right? Are we all just better off when we buy a car, paying $100 extra, have it go to plant trees somewhere and keep the car running, so it doesn't spend more time in the shop than it should? I mean, it's big picture, small picture, long casting, short casting. There's a lot of variables there, and there's a lot of countries heard from, so to speak, in that discussion. But
yeah, I'm pretty excited, and on that one, I think I can't remember the exact conclusion, but I think someone's actually done the work on the lifetime impact of those start-stop motors, and I don't think the green impact is as robust as the initial intent was. But I do think that there's the advent of something brand new is at foot here, which I think is going to be really interesting, especially from a reliability standpoint. Imagine a car in the future that is a shared, kind of a shared service car. Maybe you own it with a couple other people, and then it also is an income solution for you because it drives around autonomously, running people around. Effectively, you have a car that runs 24 hours a day through the life of the car, and it's an income generator for you. Now imagine the reliability we're going to have to design into that car. It's at a whole new level, because even our cars today, they run, they run a certain number of miles before they have problems. It's typically you get a 60,000 mile powertrain warranty, maybe 100,000. But there is a point at which these things start to fall apart. And then there's just time on the road versus time in your garage. All that wear and tear creates a huge opportunity or a huge need for better electronics. And then you're like, well, can they afford it? Well, because it's an income vehicle, maybe we can. Maybe we can have the everyman vehicle be a $100,000 vehicle rather than a $40,000 vehicle, because it's not just your vehicle, it's something that's generating income. Yeah. And so now you get these super ultra reliability vehicles that have all these different characteristics. So now what is that solder? What is that thermal solution? What is that semiconductor packaging? What is that whole system look at? How do we think about modularity so we can pop out systems and put in new systems when we need to? So it's rapid repair, because time not on the road is going to cost you more. I think it's going to be a really fun, innovative cycle that's going to happen. We're not quite there yet. It's on the cusp, but I think it's going to be here sooner than we think.
Yeah, I totally agree. And that's going to require not just technological advancements and changes. It's going to require cultural changes. Oh, yeah. A lot of cultural changes, particularly in the United States, where we are probably, arguably, the biggest car culture in the world, right? Where I spent a lot of time in Europe, and in Europe, there's a certain amount of a car culture, but cars are really a utility, right? They're an A to B thing. They're less of a status symbol. There's people just don't go out for Sunday drives, or I mean they do, but I'm stereotyping. But in general, it's not like the United States that has I-10, which is 3,000 miles long, and a huge interstate system, and commercials that glorify driving, and driving is synonymous with who you are, your identity, the type of car you drive, all the supermodel stuff and supercars and all this. It's definitely, I don't think people are going to buy Lamborghinis and then, rent them out, it's, I think you're right. It's going to be shared. It's going to be very utilitarian, and we will have to get status somewhere else, maybe in our bicycles. Who knows where that's going to go. Process issues often stem from upstream material decisions, maybe decisions that don't even start with Indium Corporation, but how does your team collaborate with customers to ensure that the materials they select are compatible with the realities of manufacturing variability? You're given a set of ingredients. You're like a baker in a kitchen, and they give you all the ingredients, and they say, okay, make a souffle. But they gave you garlic, onions, and oil. You can't make a souffle from those things. How are you working in that environment where you don't own the entire process, yet the perception is it all starts with you, right? So,
yeah, I mean, it's very common, right? You get a component that's not very solderable, or you get a design that is not really manufacturable, whether it's the spacing or the pitch. And I guess, Mike, for us, what we've been able to do over the years is, because we bring our engineers to the factory floor and really work with our customers on how they're using our material, we're often there shoulder to shoulder with them. And then we combine that with the fact that we have a portfolio of products, and we're willing to develop for our customers new solutions. So very often we're that last ingredient that we're modifying to say, well, maybe we don't have we thought we were going to add some olive oil or some butter, and we're going to have to add margarine and I don't know, coconut oil or something else, because that's what is needed in this solution to make the souffle, as you said, work really well. And I think the ability to stay flexible with what we bring to the customer is really key. Now, on the other side of it, we need to cultivate trust with the customer, that they're willing to try something that might not be in their mainstream. And that is, fortunately, with Indium, over the years, we built a lot of that trust. They know that we stick behind our products. We don't rationalize our product line. So if we have to develop something a little bit unique for them to achieve the reliability profile they want in the system that they've designed, then that might require us to say, they can trust us that we're going to make that for the life of that product. So one of the really interesting products we have right now, was exactly this, is we needed to create a larger standoff in a certain bond of between two devices, and that standoff was needed to be a certain height because if it collapsed too much, the stress buildup in the joint would be too great, and you get cracks. No, so we didn't design the whole module. We didn't design the substrate. We didn't design how big the pad of solder could be. But what we had at our disposal was creativity. And so we ended up creating a standoff technology where we incorporate other components into our solder paste to make sure we create a high enough standoff. So we make sure we deliver that bond line. And by doing so, we're able to achieve the reliability and still meet their processing conditions. But that's only possible with someone who's willing to be creative on the other side. And so, fortunately, in this case, our actual R&D team, our application engineering team, and the customer's development team all worked together and built that trust through an iterative process, and we were able to bring that product to market. I love it when that happens, though. You just think about the value created in that moment.
Yeah.
It is really spectacular.
We're almost out of time, so I just have a couple more questions, Ross.
Sure.
And then we'll let you go CEO of the company, right?
Okay, sounds great.
Keep making the magic happen. What's one outdated assumption or common misconception about soldering materials and reliability that you believe the industry should revisit? In other words, what's the one misconception that just won't die?
Well, one of those, we've talked about it already a little bit, is this idea that voiding is so important to reliability. So now we have the avoid the void. We are very proud of our low voiding products, and we're excited about it. But in many assemblies, the voiding level just doesn't matter that much, but I would say that the emergent applications, voiding matters a lot. A lot of these EV applications, the thermal flux through the joints is really high. Mm-hmm. AI applications we talked about, voiding really matters there. But there's still a lot of applications where a little bit of voiding probably doesn't really drive that much reliability concern. The other one I would say is that there's only one alloy. Hey, we only use SAC 305, or we only use, back in the old days, tin silver,
6337,
or whatever, 6337 or tin lead, the standard tin lead, or whatever their mindset is. They get, I've used this alloy. This is our alloy. This is the only alloy. Right now, companies are building millions of products with dozens of different alloys right now. And they're achieving reliability. They're achieving good throughput. They're achieving good solderability. The whole assembly is still coming together to meet the requirements of their devices. And there's a far, if the users and the designers open their minds up to how many different alloy combinations are possible, I think they can maybe have the real breakthroughs in reducing costs, improving sustainability, and also actually delivering a better product for their ultimate customers.
Yeah, excellent. And finally, Ross, time to get out the crystal ball. And,
okay.
These podcasts are evergreen. They live forever. So 5 years from now, we're going to look at this and go, this is what Ross said. Let's see if he was really a prophet. As you look into the future of soldering materials, what are you most excited about? And what do you see as the next major reliability challenge that still needs to be addressed? Things that are going to keep you and your team up at night.
Yeah, so I think I'm most excited about all the opportunities for thermal management right now. I know that sounds, and again, we're largely doing PCB assembly, but thermal management's coming to you in a big way in the SMT assembly and PCB assembly lines. Thermal management is so dynamic. There's so many novel materials, so many interesting ways to solve it. We have a whole thermal R&D team that's right in the thick of this. We're doing new test builds every day almost for customers. It is a really exciting and dynamic time for thermal management. And I say that just because miniaturization, the fine features that we're seeing in these semiconductor devices are creating a whole new need statement for the thermal management. So that's a really fun area. I think that's still going to be an exciting area and a dynamic area for Indium even 5 years from now. Mm. The other thing I want to say I'm just thankful for, and I guess maybe this isn't so much a prediction, is everything we do today, we'll be doing still 5 years from now. One of the things, if you've been in this industry, remember the old days of, well, wire bonding is going to go away, or wave soldering is going to go away, or whatever. Everything we're doing now, will continue to be with us and keep growing. The reason that's important is that really fuels the resources that you need to develop that next generation product.
Yeah.
And so I am thankful for that. Now, from a reliability standpoint, the biggest concern I have, or maybe we're hitting up against what might be a limits unless we come up with something that's really creative, is the fine feature applications. System and package, the heterogeneous integration that is going on in at the semiconductor packaging. The front end modules, for example, for cell phones. These devices are so small and they have such tight feature sizes. And we're going type 7, type 8, type 9 powders. We are starting to glimpse the end of that progression. But I don't know if it's going to be an end, because I don't know what I don't know right now. But I think that is going to be an area where we're going to still be working the trade-offs, figuring out the dynamics of the material. What else do we need what ingredients do we need to add? What process tools do we need to develop and invent that's going to enable that feature size to keep getting smaller while still getting all the benefits of solder, which has been around with us for thousands of years. It's still one of the best interconnect technologies because it's just so robust, and that's why it's fun to be in this industry. This technology is really going to be with us for a long time, and the innovations we have today will hang around for a very long time.
Yeah, I completely agree. We talked earlier about Moore's law, and Moore's law basically is the number of transistors that get on a chip will double or whatever every so often, and there's a lot of legitimate talk and concern about, are we kind of at the end of Moore's law? I mean, how many billions of transistors can we put on a little piece of silicon? And then IBM and others totally changed the paradigm. They said, oh, well, why are we trying to put transistors on silicon? Why don't we just write the on-off on an electron and not use a transistor, not have silicon based? Oh my gosh! Now all of a sudden they have these supercomputers that are just. I watched an interview today with one of the lead engineers at IBM, and he was explaining that with a given calculation, a very difficult calculation, every supercomputer in the world currently in use, all connected together, combined processing power, would take about 1 billion years to come up with a calculation that this computer can do in a few seconds. Boom. Mind-blowing, right? It's absolutely crazy because they changed the paradigm. It's no longer how many transistors can we stick in silicon. They just went in silicon. They just went, why use silicon? Let's just dramatically change it. So I think to your point, the legacy products will still be there. We're never going to give them up. There are still people, running wave solder machines on primary production. There's still people hand soldering and primary production, certainly rework. There's still people with through-hole component placement machines, cut and clinch machines, things like that. That the young people are like, cutting what? Yeah, I mean that's what I cut my teeth on. They're still out there in smaller numbers, but they're not going away. But I think at some point there will be a paradigm shift, and soldering materials and cleaning will morph into whatever is in vogue at that time, and right. We will adapt. Indium will adapt. Other companies will adapt, and it's an interesting time. I think we are. It's not often I can say I'm witnessing history being made, because normally that is with perspective, right? And it's over such a long period of time. It's multi-generational, so no one generation gets to remember. I mean, people saw the airplane come into being. People saw the steam engine come into being back in the day. There were some milestones. I think we're seeing the greatest amount of evolution and revolution in our lifetime, just in our adult lifetime. And it's fascinating to see history being made, whether it's through EV or quantum or AI or whatever the next buzz technology is going to be. We're seeing it at light speed, and where other where our ancestors saw it over thousands of years, we're seeing it over a few thousand days and sometimes a few thousand hours. So I find it an incredibly exciting time to be in the technology world.
Absolutely. I mean, technology, it's been a great industry. It is a great industry. It'll keep being a great industry going forward. And, a lot of people are worried about how does AI transform the world going forward? And it's going to be fascinating to see. But one of the things that's great when you're in the industry that's building the hardware that runs things, hardware still matters. Materials still matter. Material science still matters. And we're right in the thick of all of that. And I had our owner for many years, Bill McCartney, said, I just wish I could be around for the next 50 years to see what's going to happen next with this company, with our industry, with our customers. And I feel the same way. I think the next 50 years are going to be so much more exciting than the last 50 years and on. 100%. It's just really an amazing time to be alive and to be part of this industry.
Yeah, 100%. If there's a strive to live longer, which is human nature, most people want to live longer because they want to spend time with their friends, their family, their loved ones, et cetera. All that is there for me. But in addition, I really want to see the next gen of spaceship or aircraft or, technology, a car, whatever the case may be. I'm so excited. I don't want the movie to be over. I just want to live it as long as I can. Well, Ross Berntson, thank you so much for your generous donation of your time and your wisdom and your insight to not just soldering materials, but the industry in general. And thanks for talking to me and my audience, more importantly, and educating me and my audience as well. For my audience who's watching this on YouTube, if you look down here, you'll see it says see more, and you'll see information on indium. I'm also going to put a reference to the book Range. Ross brought that up as worth reading, so I'll put a reference to there as well and a link. And if you're listening to this on your favorite podcast app, when it's safe to do so, don't do it while you're driving. When you get to your destination, go to that podcast app, look at the show notes, and information on indium and the book Ross mentioned will also be there. So Ross, thank you so much. I wish you continued success for another 30 years at the helm of indium. And keep the good work going, and get some clever marketing campaigns out there. I miss the Obsessed by Solder Paste. Maybe you ought to put on the goggles and crawl through a reflow oven, just for old time's sake.
I'll take on the challenge, Mike.
I'm going to challenge you to do that. Yes, exactly.
Okay.
And then we'll bring you back on the show, and we'll talk about what it was like to crawl through a reflow oven.
Fantastic.
Or a wave solder machine, I think is what it was.
Yeah.
Very
absolutely.
good. Well, thanks, Ross. I appreciate your all the time.
Thanks for having me, Mike. Look forward to talking again soon.
Same here. And that's a wrap on another episode of Reliability Matters. Thanks for hanging out with me. Whether you listen to this on your favorite podcast app or watched on YouTube, I really appreciate you being here. If you haven't already, hit that subscribe button so you don't miss future episodes. On YouTube, give it a thumbs up and subscribe. Those two simple clicks really helps us expand our reach. New shows drop on the second and fourth Tuesday of the month, so mark your calendars. And a huge shout out to PCB Chat from the Printed Circuit Engineering Association at PCBchat.com and Ascendo Reliability at reliability.fm for syndicating the show. Got a question or an idea for a future episode? I always love to hear from you. Just shoot me an email at mike@mikekonrad.com. That's Konrad spelled with a K. Want to learn more about the podcast? Just head over to reliabilitymatterspodcast.com. Thank you so much again for being here. Until next time, keep learning, keep doing it right, and remember, reliability matters. I'll see you again in 2 weeks.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.